Since we're dealing with the function y equals 2 times x, and we're trying to estimate the area of the region R, which is given between 0 and 10. They've asked for us to use 15 rectangles to estimate the area. So the first thing we have to find out what our delta x is. So delta x is our last region, last boundary, 10, minus the first boundary, and that's x equals 0, all divided by the number of rectangles. So we have 10/15, which reduces to 2/3. That means our first value where delta x is being slid over from 0. Okay, so our base is 2/3, and so that first x value is 2/3 as well. If we use our calculator and we have our sum, we need to multiply everything by 2/3, and then we're going to add up the sequence. Again, our function is 2x. We're going to evaluate that through x values. We have to start at 2/3. We're looking to end at 10. And we're going to have our step value as 2/3. If you put that into your calculator, I believe that you get 106.67. On part B of this problem, instead of having 15 rectangles, they have indicated that in this region in here, we have a total of n rectangles. So our delta x is going to be set by 10 minus 0 over n. So we have 10 over n. The summation of each of those rectangles would be our base, which is 10 over n, times the function value at each of the right hand values of y. So our first value would have to be the function at 10 over n, because we're going from 0, we're moving over delta x over 10 over n, so that first x value is 10 over n. The second x value, well, that's going to be, we started at 10 over n plus a delta x of 10 over n, so our second one is going to be 20 over n. So back to our summation here, we'd have to take our function, we'd have to take our delta x and multiply our function values of 10 over n plus the function value at 20 over n plus our function value at 30 over n plus, get rid of this, and then we'd have to just keep going for however many rectangles we'd have. And eventually, though, our last rectangle, since we're trying to get to 10, we're adding up, don't forget we're adding up widths of 10 over n, so we'd have to have 10 over n over n. And you may be thinking, isn't that just the function value at 10? And the answer to that is yes, but for the calculations that I'm going to do momentarily, leaving it as 10 over n would be advantageous. So if I have, thinking about the function values, well, the function is y equals 2 times x, so we'd have 2 times our function value at 10 over n plus 2 times 20 over n plus 2 times 30 over n And each of these would end up giving us our y values. And the last one would be 2 times 10n over n. If we're going to do some algebra here, so each of these terms have a 2 in them, so I could factor that 2 out, and 2 times 10 over n would be 20 over n. Now, each of the terms also has a value of 10n involved with it. So if I take and I factor that out, 10 times the 20 here, well, it would be 200. Now, if I'm factoring out an n in the denominator, I'd have n squared. I'd be left with 1 plus 2 plus 3 plus all the way down to n. Now, on part C, it says use the formula 1 plus 2 plus 3 all the way up to n equals n times the sum of n plus 1 all divided by 2 to simplify the expression that we just found. Well, if 1 plus 2 plus 3 all the way up to n equals n times n plus 1 over 2, then this part of our terms up here can be substituted with n plus 1 over 2, and I still have to multiply that by the 200 divided by n squared. If I simplify that a little bit, well, 200 divided by 2 is 100. I still have my n plus 1, but the other n on the numerator can be canceled with the n squared, so I'd have n on the denominator. I can take that a little further by multiplying the 100 in, and I can think of those, each term, as divided by n. So that's just some fraction work, so I have 100 plus 100 divided by n. In part D, they're asking us to take the limit of what we just found, this whole term. We have now simplified it into 100 plus 100 divided by n. Now if I take the limit as n goes to infinity, this first term of 100, that's not affected by n, so it's just 100. And the second term, 100 divided by n, well, 100 divided by infinity, some huge number, the overall fraction just keeps getting smaller and smaller, and it goes to 0. So our limit is just the 100. And then what's the actual geometric interpretation to your answer in D? Well, that's the actual area of the triangle. And if you think about it, the original picture was a triangle between 0 and 10. We had 2 to the x as our function. So 10 times, this would give me a highest value of 20. So my base would be 10. My height would be 20. And the area of a triangle is 1/2 my base times my height. So I have 1/2 10 times 20, and that is 100.